Alright, we're going to move to geometric series now, and just a reminder that a sequence versus a series just means we're adding up the terms of the sequence. So we've established the formula for the nth term of a geometric sequence, and just a reminder that in a geometric sequence we're multiplying by a common value r each time to move from term to term, which gave us this formula. What we want to do now is find out if we were to add up all the terms of a geometric sequence from the starting point up to our end point, up to our t1 r to the n minus 1, what would we get? What would be the value of this? Now, what we want is, instead of actually having to physically add up all these terms, is there a formula of some kind that will give us the value of this? And we're going to go through a formal proof of that in a moment. But just to warm you up to the idea that I'm going to use in that proof, let's look at an example with some numbers. So I have here my geometric series in which r is 3, and I'm going to show you a process by which we can find the sum. And it's going to involve a system of equations, and it'll be somewhat similar to the process I used to establish the formula for an arithmetic series. So what I'm going to do here is I'm going to take this given series that I want to find the sum of, and I'm going to take this equation, number 1, and I'm going to multiply it by 3, which is my multiplier. Multiply both sides of equation 1 by 3 to get 3s4 equals, this would be 6, 18, 54, and this would be 162. Alright, I'm going to rewrite these equations. I'm actually going to put equation 2 on top. 3s4 equals 6 plus 18 plus 54 plus 162. And equation 1, s4, I'm going to write as 2 plus 6 plus 18 plus 54. Now you're probably sitting here thinking, how come he wrote one sequence a little bit over from the other? And if you look at it, you'll probably realize it's because the terms in each sequence in the middle here are the same. So if I now subtract the equations, 3s4 minus 1s4 equals 0 minus 2, negative 2. 6 minus 6 is 0. These all become 0. And then 162 minus 0 is 162. I can then factor s4 out of this side. Okay, I'm just reordering a few things in my simplification. I did some factoring out on the left. And now if I isolate s4, 162 minus 2 over 3 minus 1, and if I work that out, I'm going to get the sum of the sequence I began with. Now the question I want you to consider is, can I see where these numbers are coming from in terms of my original series? Well, the 3 here is our r value. The 2 here is my first term, term 1. And my 162 doesn't actually appear in the original sequence, but it is the value of the last term multiplied by r. In other words, Tn times r. And so what we're thinking possibly is that the sum of n terms is Tn times r minus T1 all over r minus 1. Okay, let's do this process now in general, and we'll see if we actually come up with this result. So I have my series written out, the sum of n terms of a geometric series. And as I did with the numerical example, I'm going to take this equation and I'm going to multiply both sides by r, the common ratio. So I'm going to get as follows. The last term will be term n times r, and the previous term would then be Tn. Now I'm going to rewrite the two equations so that terms that are the same line up, terms such as these. And then I can subtract the equations, equation 2 minus equation 1. All of the middle terms subtract to 0. Now I'm down to a point where I can simplify, factor out Sn. Divide by r minus 1. And I come up with the formula I had in the numerical example. So it is true that this is the sum of the first n terms of a geometric series, as long as r isn't 1, because that would involve division by 0. Alright, now because we also know that term n, the formula for that is term 1 times r n minus 1, it's a multiply sign there. What we could do is create a second formula by substituting this in place of Tn. And if I multiply my powers of r, I add the exponents. And so I'm going to get T1 r to the n minus T1 over r minus 1. Or if I factored out T1, I get this. So any of these two forms will find us the sum of n terms of a geometric sequence. So we could use either of these formulas to calculate the sum, depending on what we were given. Here's an example. Find the sum of the first 10 terms of this series. And it is geometric. We are multiplying by negative a half, so that's r. Our term 1 is 4. And we're being asked to find the sum of 10 terms, so that would mean n is 10. Now, the most straightforward formula to use for this would be the first one, because we have all the ingredient variables. So the sum of 10 terms would be 4 times negative a half to the 10th minus 1, all divided by negative a half minus 1. Just before putting this into the calculator, let's just note that this would be negative 3 over 2. Alright, let's type this in. 4 multiplied by bracket negative 1/2, which I'll just put as negative 0.5, to the exponent 10 minus 1 divided by negative 3 over 2. Calculates out to 341 over 128. Now, if I had chosen to use the second formula to calculate the sum, I'll note that I would need to know the value of Tn. Well, that would be easy enough to calculate because I know the formula for a geometric sequence to be this. And so term 10 would be minus 1 is 9. If you check that out on the calculator, that's negative 1 over 128, which you could then use that value in this spot. And so the sum of 10 terms would be negative 1 over 128 times r, which is negative a half, minus term 1, which is 4, all over r minus 1. And so this is 1 over 256 minus 4, all divided by negative 3 over 2. And if I plug this into the calculator, I should get the same result as up above. And indeed I do.